Welcome back to yet another solution video from IB League Math. Here I am solving paper 3 of application and interpretation time zone 1 and the question number 1. This question is about modeling a spread of computer virus to predict the number of computers in a city which will be affected in a city. Yeah, so big number. A system analyst defines the following variable in a model. T is the number of days since the first computer was infected, and Qt is the total number of computers that have been infected, including the day T, up to T day T. That's what it is trying to say. The following data was collected. Okay, this is the data which looks exponential. A part, find the equation of regression line, equation of the regression line of Qt. So line, okay, so we have to find the equation of the line of regression, which will be y equal to mx plus c format. Okay, so what we'll have to do, we'll just input, it's just 2 marks, so we can input in our calculator and get that. So let me use my calculator for this. Okay, I have uploaded this table here, and there is an additional column of frequency. Please ignore it because they are 1 1 1, so we have 1x and 1y, and we are having this. So let me calculate it. Okay, regression, calculate. Okay, and we got this here, y equal to let me write it on my this one. So A is negative 54042 and B is 3094. So if I want 3 significant figures, this will become negative 5400, and B will be 30310. Yeah, 3090. Okay, 3090, we can do it. And R is 0.755. Okay, so M came out to be 3090 and C came out to be minus 54003 significant figures. Okay, and what is the question? Find the equation. So we'll write the equation now. Qt, which is y, equal to 3090 x, not x, t, minus 54000. This is the equation of regression line. Write down the value of r. We just got r also, so second part of the solution is 0.755. This is what we got. Number 3, explain why it would not be appropriate to conduct a hypothesis test on the value of r. Okay, there are so many ways, so many reasons we can find a hypothesis test on this. Two, mainly you can see that it is just increasing exponentially. So we wrote a linear equation, but the growth is exponential, not linear. Or we can say that the distribution, if you remember, the frequency was 1 1 1 1 for each, so distribution is not normal, distributed. Let's move on to the B part of this question. A model for the early stage of the spread of the computer virus suggests that this differential equation, this is the first derivative, right? Where n is the total number of computers, this n, okay, in a city. Beta is the measure of how easily the virus is spread between the computers. Both n and beta are assumed to be constant. Okay. B part, find the general solution for the differential equation. Okay, so this is the equation. So let's substitute q prime t by y. It will become easier for me. So I can write dy over dt because it's the differentiation. beta is beta, n is constant, and qt is the function, which is y. Yeah, the differentiation y is dy over dt with respect to time, and that's what it is. It is differentiation of qt. Okay, so now to solve differential equation, we can take dt there and y will come under dy. Yes, this is part 1. So we get dy over y equal to beta n dt. Yeah, and now if we integrate both sides, what happens? It becomes 1 over y dy equal to beta n dt. So 1 over y dy, the integration will be natural log of y equal to beta n, and integration of dt is just t, and then will be plus c. This is the general solution of the differential equation, but there was no y. Y was my creation, so I will put it back. Ln y, which is qt, equal to beta n t plus c. Okay. Next, number 2, using the data in the table, write down the equation of an appropriate non-linear. So as we saw earlier that the linear was not a good choice, because it was linear, it was exponentially increasing. So let's use some other software for this, because my calculator is not showing any capability. So I'm using numbers here. So let me show you the table first. This is the table I've copied here, and I've got this perfect, can you see, exponential graph, and I have to find the equation for this. So I will go there. Okay, and I have to show, okay, I have to show equation, and r square is also needed later. So here it is. This is the equation, y with equal to 1.1486 and 0.2921, and r square is 0.994. Okay, 1.1486 e to the power 0.2921 t. That is the one. What are they saying? Using the data in the table, write down the equation of the appropriate nonlinear regression. That is the one. Okay, number 3. Write down the values of r square. We got it. R square was 0.9994. Hence, comment on the suitability of model from B2, this one. Okay, in comparison with the linear found in part 1. Okay, so the non-linear regression is better suited as r square is nearly perfect. So actually it is 0.9994. By considering large values of t, write down one criticism of the model found in B2. Okay, so by considering large values of t, so let's see what is the t for us here. 40 days only, right? So suppose this is for a city, isn't it? Yeah, a city has fixed number of computers. So what happens after long period of time? Either all computers will be infected and numbers will not increase, right? Or there may be an antivirus which will seize or reduce the number of infections. So this exponential growth will stop and this will not be applicable anymore. Part C, use your answer in part B2 to estimate the time taken for the number of infected computers to double. So what was it? It was 1.14862921. Okay. So QT was 1.1486 e to the power 0.2921 t. So in an exponential growth, this is the growth over this original value. That means initially these many computers were infected. 1.14 is not a number of computers, right? But because it was a regression, that's why it gave us 1.14. We will double this to see how much time it will take this original number to double. So 1.1486, if I multiply this by 2, whatever that is, let me write it here. The final value will be 2 times 1.1486 equal to 1.1486, this is the regression, e to the power 0.2921. So both sides have 1.1486, we can cancel it out. So 2 equal to e to the power 0.2921. To remove this e, the other side will become natural log of 2 equal to, I didn't write it here, 0.2921 t. So t will be ln 2 divided by 0.2921, and that's what we will put in a calculator and we'll get this. So let's see. Ln 2, okay, divided by 0.2921, 2.37, okay, 3 significant figures, 2.37 days. So it is going to be t equal to 2.37 days. These are the days in which the number of computers will be doubled which are infected by the virus. Okay, the data above are taken from city X, which is estimated to have 2.6 million computers. So this is for part D. N of X city is 2.6 times 10 to the power 6 million, right? That is millions computers. The analyst looks at the data from another city Y, and beta for Y is 9.64 times 10 to the power minus 8. Find in which city X or Y the computer virus is spreading more easily. Justify your answer using results in part B. So we know beta for Y, and beta by definition, by definition beta was, let's see what was the definition of beta they have written here. Yeah, beta is a measure of how easily the virus is spreading. That means if beta is more, the virus is spreading easily, and we had this equation. Let me, okay, I'll memorize this one, and we also got the same equation here. Let me write it here. QT equal to beta NT plus C. Let me see once more. No, it is natural log. Okay, so it is natural log of QT is BNT plus C. If I compare this with the equation I got here, this one, can I convert this equation like this? I have done it already here, but I gave it a number, that's why I can't say that. So let me write it here. E to the power something, let's say X is 1.1486. So x will be natural log 1.1486, and let me use my calculator for this. 1.1486 is 0.1385. So 0.1385, that means this here equation becomes qt equal to e to the power 0.1385 times e to the power 0.2921 t, and now both have same denominators, so we can write qt equal to e to the power 0.2921 t plus 0.1385. And now if I remove e from the right side, the left side will become ln qt equal to 0.2921 t plus 0.1385. So we can see here that bn ln qt b t is there, t is there, c is there, c's value is this. That means 0.2921 is beta times n. So 0.2921. Let's go back to the question where we were doing this. So for CTX, 0.2921 equal to beta, and number of computers in CTX are 2.6 times 10 to the power 6, right? And t, okay, no need to write t, we compared it already, right? So beta is equal to 0.2921 over 2.6 times 10 to the power 6, and if we do that, 0.2921 divided by 2.6, which is 0.1123 times 10 to the power minus 6. So if I bring this here, it becomes 1.123 times 10 to the power minus 7, right? And now compare this beta of x with beta of y. Which one is bigger? This one is bigger. Yeah, it is 10 to the power minus 8. This is 10 to the power minus 7. Both are in standard form. So we can say that beta x is greater than beta y. So it is easier to spread in CTX because its beta value is greater. Okay, what else we have here? Find in which city, okay, we've done that. An estimate of q prime x, derivative of qt, for more than t to 5. So yes, it is more than 5, so that's fine. This onwards can be found by this. Okay, the following table shows q prime t for CTX at different values. So some of them they have already given to you. A and B are unknown. Determine the value of A and B, given your answer correct to 1 decimal place. So let me do this on this side. Yeah, they have already given this, and q prime t we have to find here for these values. Okay, so q prime t, which is A in this one, A in this column is almost equal to 10 is the denominator fixed, q t plus 5. So t for A is 15, 15 plus 5 is 20. So what is q t q20 403 minus q t minus 5. T is again 15, 15 minus 5 is 10. So what is q 10 20? So A will be 403 minus 20 is 383 over 10, 38.3. And that makes sense. 38.3, 171, it is less than 171, so 38.3 makes sense. Okay, for B, same thing we'll do for B. So Q T plus 5, so that means 35, 32,667 minus for B, T is 30, so T minus 5 will be 25, Q T minus 5 is 1806. So it will be 1, then 6, then 26 minus 8, 0, 3 over 10 equal to 3086.1, which we can round off to 30903 significant figures. Okay. An improved model for QT, which is valid for large values of t, is the logistic differential equation, which is this. Okay. Where k and l are constants based on differential equation q prime over qt against qt is predicted to be a straight line. It means q prime t over qt is the dependent variable, let's call it capital Y, and qt is the independent variable x, is predicted to be a straight line. Use linear regression to estimate the value of k and l. So we again have to use linear regression, but for that first we should know the values of x and y. So let me make a table here. So x first, the independent variable x will be qt. So it will be okay, we don't have q prime t for 20, so we'll start from 90. Let's start from 90. Next is 403, 1806, and then 8070, and finally 32667. And y, capital Y, will be q prime t divided by qt. So a divided by 90. A we got how much? 30 something something. Let me see. 38.3. So it will be 38.3 over 90. Then what do we have? We have this 171.6 over 403. 171.6 over 403. Then 766.7 over 1806. Then B value was 3086.1. Divided by how much? 8070. 8070. Then finally we have 11207.6 divided by 32667. Let's put this, it will take a lot of time to enter this in my calculator. Let me cut this video and straight away show you after entering the same thing. Okay, so it's entered here. I have entered x and y. Frequencies are still 1, and now we will find the equation for this. Regression calculate, and we got here a, which is a constant, 0.4222795, and the gradient part is negative 50255,609. Okay, so the m part, the gradient part is minus 1 2 3 4 5 2 5 5 6 0 9. Okay, let me confirm once more. Okay, so we got it. Nobody's asking R, so we will stick with what we got. All right, so now I will convert this one to a y equal to mx plus c. Y equal to mx plus a in this case, right? We found constant part a. So let's do this. Q prime t, this one, divided by this qt will be, because qt has become denominator to the left side, so k will be left here. So k 1 minus qt over L. Okay, which is k minus q, okay, k over L qt. Okay, this qt was our x and this whole thing was our y, right? That means the constant part k is this. So three significant figures we can write 422. Okay, so they wanted us to find the value of k, which is 0.422. Now m gradient is this small number, and which is k minus k over L. This is the gradient part. So let me do it here. Minus, okay, let me do down there, not space. There's no space there. Minus k over L is equal to minus 0.00000, 5 zeros, 2555609. And our purpose is to find L. Both are negative, so we can cancel them. So k we already know. K was 0. Let me write the whole value. 0.4222795 over 0.0000255,609 equal to L. So cross multiply, huh? L went this way and this came down, and this is how we can find L. Let me use my calculator to do that. By the time I do this, I would request you to like this video, share with your friends, and subscribe to my channel. The rate at which my subscribers are changing is very low, so I hope you will help me to get my target of say a 150 very soon. Thank you very much. And what I'm getting here is 165,205.2549. Three significant figures will be 165,000. This is the value of L, and we got the value of K already. I wrote it here. All right, what is next? Okay, the solution of the differential equation is given by this, where C is a constant. Using your answer part F1, okay, the one we got K and L. Okay, estimate the percentage of computers in the city X that are expected to have been infected by the virus over a long period of time. That means time is infinity, we can say. Okay, all right, so let's do it. QT, that is the number of computers, right? Number of, what are the things that are expected to be infected. So QT is the one. Equal to L. L we got how much? 165. Let me write the original value. 165,205. This one. 2549 divided by 1 plus C. And what is C? C is a constant. Some constant. E to power minus K. K is a very small number, 0.422. But since we are talking about long period of time, that means time is many days have passed, say infinity number of days. So what happens because of this infinity, no matter what is this value, this whole thing will become infinity. So let me focus on denominator. So it becomes 1 plus C e to power minus, so let me divide by e to power positive infinity, right? 0.422 times infinity will be infinity, and because it's a denominator, e to power infinity is again going to be infinity, a very big number. C divided by a very big number, no matter what is C, it will be almost 0, right? So it becomes 1 plus 0 or 1. The denominator is 1. That means number of computers that will get infected will be 165,000, which was the value of L. However, the question was not about how many computers are infected. They are saying the percentage, estimate the percentage of computers that are infected. So 16, let me again use the proper, let me write here, percentage computer infected. So they are 165 205. Out of how many were they? They were 2.6 million. 10 to the power 6. And we want to find percentage, so we have to multiply this by 100. And the answer I'm getting is 6.35%. Only 6.35% computers will be infected over a long period of time.